Quality of service. I already told you that congestion control as well as quality of service, both are bounded together. So while we are discussing about the congestion control mainly avoid the traffic. But when you go with the quality of service, during the data traffic also, my data has to be delivered with quality. So that is quality of service. So while we're seeing that in congestion, it is performs well by avoiding the traffic, but quality of service, including the traffic also, it performs well. That is the thing. So this is the quality of service. We have already seen that. What are the flow characteristics are needed for the quality of service? What are the things? Reliability, delay, jitter, bandwidth. Okay. So I think this we have seen about the reliability. While I am sending any of my data, it always to be prioritized. The data may be in the form of voice or in the form of video or in the form of data. So what they will do, they will put the router in the priority order. We all know the router is a device. So we have a high priority, medium priority and low priority. Why? Because now data, we all know that data will be stored in our mail or will reach the using the file transfer protocol transfer concept. But that when we receive late, it will not be done much problem to the circuit, problem to the network. But when you go with that high priority and medium priority, what will be the problem now? I'm talking to you now. Okay. If my voice is not reached to you properly, you cannot able to listen the class. So the most priority will be given for voice. Most priority is given for voice. The next priority, video. Whatever I'm speaking, my video, you all know this video has to be also there. So the next priority is given to the video. And the last priority is given to the data. So that the quality of service, they were saying that consistent and predictable performance, I will get it while I'm transferring my voice first, video next and data next. This will be the priority which is given here. And this is one of the very important diagram, how the converged network quality issues. Okay, you just see in the wireless LAN, I have connected one of my campus, and here, this is my remote campus and this is my main campus. Okay, so constant small packet voice, that is bursty data flow. What is bursty data flow? While we are seeing that in particular period only, my data flow will become high. That is bursty data flow. So during this year, my data rate will be there. My data rate will be there. And here when you see with my time period is there. So sometimes there will be no data, but sometimes the data will goes to the peak. But during this bursty data flow only, I am meeting the problem of congestion. So the critical traffic, that's why they told you get priority, and voice and video are time sensitivity. Okay, data is not some sensitivity. While I'm transferring my audio through video, all this video conferencing happening, all this are time sensitivity. Okay, and then brief outrages are not acceptable. So converged traffic characteristics, we have to avoid the bursty data flow. We have to priority the packets, and then voice and video are time sensitivity. So we can transfer in after a particular time with good quality, that won't be reached during the video conferencing and all. Okay, and outages are not acceptable. So that any power outages are not, that is not acceptable. So these are the thing they were saying about So while we seeing about the remote campus and main campus, I'm transferring any data now. This is transferred with one value, and this is our transferring with one value. Now you all know that this all the traffic characteristics should be incorporated. Okay. Now when you see to that, lack of bandwidth, packet loss, delay, jitter, that we are going to see to that in detail. Okay. Now you see lack of bandwidth while I'm transferring my sender to receiver. Okay, this is my sender part and this is my receiver part. Okay, and you see here what is the time data transferring here, 10 Mbps. And here, what is the data transfer? 100 megabit per second. While I'm transferring to this router, my data speed will become 256 kbps. Okay, but when you see to that, what speed it will reach from sender to receiver now? 256 kbps, because 10, 256, 512, 100. But my sender have been transmitted the router with the 256. Now it will take the 250 kbps transfer. But you all know that while I'm transferring, my bandwidth available will be calculated. Bandwidth maximum by flow. So while we see to that, my measuring available bandwidth should be matched with my source to receiver side, or else there will be a problem on receiving the packet by having the less bandwidth. So we have to be always because it is getting 100 Mbps and I'm transferring 256 Mbps now. You just imagine there is a lack in bandwidth can have an impact on the network applications. Okay. Impact of packet loss. I told you that while I'm sending my data, I always have a this is my router. We have a input output queue, processing queue, output queue in that. So sometimes my packet get done, tail may be dropped. Just imagine I have put my source address, destination address. So tail drops are common and happening when the link is congested. So due to that also, this also will happen. So impact of so available bandwidth, that is the available bandwidth also decides the impact on the network, and impact of packet loss also leads to the congestion point. Okay. So impact of packet loss, some examples I have given. Telephone call. I cannot understand you. Your voice is breaking. This we all used to say often. Teleconferencing. The picture is very jerky and voice is not synchronous. I'm speaking one and you are getting another one now. Then automatically in teleconferencing, video conferencing, this problem will happen. Publishing concept company, sometimes the files may be corrupted. Okay. Call center, they have to please hold while my screen refreshes. So these are the impact on day-to-day application while my packet have been lost. Is clear? So this all will happen. Okay, and type of delay. We have seen 4 kind of flow characteristics: lack of bandwidth, packet loss, delay, jitter. This 4 only. So lack of bandwidth we have seen, even though from source to destination, what will be the bandwidth that will decide. Packet loss maybe leads to the tail drop, or else some of the examples we have given, and delay and jitter. Okay, now we will see the delay. Delay, we have 4 delays are there: processing delay, queuing delay, serialization delay, propagation delay. Processing delay, while you are seeing that queuing delay, it always occurs in the input or output. Okay, and processing delay, while I am forwarding my packet to other router, that is processing. Serialization means bit on the wire. Due to that, the delay will be occur. Serialization delay. Propagation, the time taken for the packet to from one end to the another end. So the delay may be in the router. 4 kind of delay will be occur. Queuing delay, it will occur in both there. Okay, that is queuing. Processing, while I want to process from my input to output and how it will be interfaced. Serialization means bit on the wire. Propagation delay means to cross the link from one end to another. That is that. Okay. Jitter, this is the next one. What is jitter now? You all understand that the delay will not be equal. You see the red color, you see my delay time periods are equal. But when you see to the next case, you see that my delay time period is keep on increasing from one packet to another packet. So that is, they are saying that we won't get the data correctly because that is due to the variation of delay in the same packet after the conjunction. So you see that due to the conjunction, there will be an equivalent delay. For example, we have seen queuing delay, processing delay. The delay is equally means that's not a problem. The delay, the variation is occur, then automatically the conjunction will occur. Okay. Now, this is the next one. Techniques to improve quality of service. While we are seeing about the techniques to improve conjunction control, we have seen conjunction avoidance, slow start, multiplicative decrease and all. But here we have 4 techniques were mainly useful for my thing. You please kindly note down: scheduling, traffic shaping, resource reservation, and admission control. Actually, we will discuss about these 4. But traffic shaking only, my leaky bucket algorithm will comes. My leaky bucket algorithm will plays a role when it comes to the traffic shaking. Is clear? Okay, scheduling. There are 4 types of scheduling is there. FIFO, priority queue, weighted fair queue, then red. Okay, so we will see to that one by one. Yes, scheduling means you all understand that scheduling will always work on the principle. Okay, you remember that it's very simple figure which my packet will be arriving. Okay, I'm checking whether it is full or yes. If it is full now, I have to discard it. No, it is in the queue now, it will be sent to the queue. You know, it is working on the which principle now? FIFO, first in, first out. So whether I have placed my packet here 1, 2, 3, 4, 5, 6, 7, 8, then automatically it will move from left to right. So automatically the 8th is moved into the queue first. Now it will be moved. Then 7th will move next. Then 6th will move next. Then 5th will. So FIFO is nothing but scheduling. They follow the schedule. Even though the quality of service, I told you during the conjunction also it will work. But why, you may ask the question, why after full also it is discarding the packet? Now there will be that I told you that during the thing I will during this packet, during this traffic also my packet will be delivered with quality. Now that also limited will be there. Okay, they may see the conjunction effort. So we have seen that even though it is a variable constant rate, that can manage. But you see, if it is in the burst rate we all know the sudden increasing of the data rate. So at that time there will be a problem. So this is FIFO queuing. Priority queuing. The next one is priority. I told you now, voice, video, data, they have a priority now. Similarly, they have one classifier. The classifier, it's an algorithm that it will separate the voice first and video next. Now high priority queue will be sent through that. You just see, this is my high priority queue and this is my lower priority queue. So for example, high priority queue, I am sending my voice, and in lower priority queue, I am sending my data. So the processor will turn on automatically. Once this queue is empty, automatically they will connect with the lower priority queue, and then that packet will be dispatched. This is called as a priority queue. Depending on the priority, we will classify. Okay. Weighted, you all understand. The next one is weighted fair queue. Okay. Weighted fair queuing means you all understand depending on the weight position. You just see this weight is 3, this weight is 2, this weight is 1. So what it's mean now? The turning switch will select 3 packets from the first queue, 2 packets from the second queue, 1 packet from the third queue. Then they will repeat 3 packets from the first queue, 2 packets from the second, and 1 packet from. So what they will do now? Weighted, depending upon the weight, they will prioritize and they will send. Okay. Then the red we have seen now, random early detection. We have 4 types of queuing. You just note it. FIMO, first in, first out, priority queuing, weighted fair queuing, and then this is the last one is nothing but random early detection. So we already discussed first in, first out queuing. It will always send the first is come inside the queue, that will be go move first. And the second, while we are discussing about the priority queuing, depending on the priority, they will empty it. Weighted queuing means depending 3 packets I want to send, 2 packets I want to send, 1 packet I want to send, that will be dispensed on the classifier. My switch will move from weight 3 to weight 2 to weight 1. Okay. And here now, this is a popular algorithm which is developed in 1993, red, random early detection. Okay. For example, if any of my packet is get slow, automatically the source has to slow down the process. Okay, that is also we have discussed while we are discussing in the point of Nagel's theorem. We have told you that silly window syndrome problem. I cannot able to accommodate all my sender data and the receiver. Now, receiver send the acknowledgement signal, but at the same time, it will send with the window size 0. So that time what will do? The source cannot able to deliver any packet to the receiver. Acknowledgement is received. We have seen already. RTO too large, RTO is too small. For to avoid that, the Nagel's theorem. So similarly, here they what they na response to last packet na source has to slow down to send the packet. Okay, they will last packets are mostly due to buffering. We all know while we are seeing about the TCP protocol, while we are sending. It is all streamed bytes. Okay, we all know that in streamed bytes mean everything will be stored in a buffer, and from buffer to buffer it will be delivered to the streaming, and receiver side again it will be in the buffer and then read out. So all this will be that they were seeing that the random ALE detection. Okay, the random ALE detection means the source has to slow down the process, or else buffer and will overrun. So that will be a transmission error. So to determine that, what are the following reasons now? Choke packet. What we seen about choke packet, we already seen in the conjunction control. So this is early detection. Now, this is my source. Okay, and this is my destination or receiver. Inside there are so many routers are there. Router 1, router 2, router 3. And router 3 is identified there is a conjunction. Now, it will send one packet to the source. That packet is called as a choke packet. Okay, choke packet, what it will do now? It will automatically tell the source that there is a conjunction now, you slow down your process. Okay, so that is a popular algorithm. This is one thing, just you to know about that. Okay, because we are all focusing on the next one is about very, very important one is traffic shaping. Leaky bucket and token bucket. Actually, the leaky bucket algorithm is one of the very important algorithm. Leaky bucket algorithm is one of the very important algorithm. Okay, and you just see to this. This is one of the, and the token bucket also. I told you that what the traffic shaping will done by this leaky bucket. Students, listen. It's one of the most important question. Who is this Magesh Bandru? How you are listening? Makesh Bandharu. Okay, yeah, listen. So while we are discussing quality of service, I want to deliver my packet with quality. We are all discussing the scheduling algorithm, shaping algorithm. Scheduling algorithm event, all will be there. Classifier will be there. According to priority will be there. Choke packet will be delivered, or else first in, first out policy. But traffic shaping, okay, listen, this is one of the very important diagram, leaky bucket. How there is a leaky bucket. It's similar to our bucket concept, leakage of bucket is in our restrooms and all, the same concept is that. You just see the flooding, unregulated data packet will be from the host computer. I'm getting to my bucket. Okay, this is the interface, you all know that. So all that unregulated data bucket will be received here. But you all know here it's all a small leakage. Okay, we all know it's like a tap. Okay, here tap and your water is filled in the tap. But when you seeing there is a small leakage in the bucket, your water droplet will come as at the constant rate. This is the concept. It's not a muchy thing. My entire data will be put it in the bucket holding packet, and from the bucket holding packet, I have a small leakage where my data will flow with the constant rate. So you understand that. So I keep on sending the unregulated packet flow. I can keep it in my holding the packets, and then through the leakage means they will send the data at a constant rate. Whatever may be the data will come here, my data will be regulated and sent with a constant rate. Okay. So this is the algorithm behind that. Okay, I will explain you with this leaky bucket concept. You just see to this figure. This is all given in the thing. No, what is this mark? Burst. You all know it's a burst profile, burst traffic profile. And this is also called as a burst traffic profile. Okay, while I'm seeing to that, you see that now my 12 Mbps is transferred you all know this is second, into 2, 24 megabit per second. Okay. And here 2 Mbps delivered with the 3 seconds, now 6 Mbps, 6. Okay. So totally 30 Mbps. I want to deliver 30 Mbps now. Why all have happened sudden raise now? They have a fixed data rate. You see, all my data rate, the value is 10 into 3. So 30 Mbps per second have been delivered. Okay. So you just imagine here all my one is receiving the data with the 12 Mbps, one is receiving at the 2 Mbps, whatever maybe it will happen, a bursty flow will happen. So to avoid that, I have to make the fixed flow. So to make my fixed flow, I taken my data rate as a 3 Mbps, same 10 seconds. You all know there is a bursty traffic have happened. Same 10 seconds I have delivered. This is called as a fixed data rate. And sometimes we used to mention as a constant data rate. But the fixed data rate may be vary, depends on the algorithm. Are you clear on this point? Okay. So same 30 Mbps, which is delivered with the bursty data flow, and the same 30 Mbps, which is delivered with the fixed data flow. Okay, now you take this example, n equal to 1000. Okay, these are my packet length, 200, 700, 500, 450, 400, 200. Okay, now I have to see that I can deliver n greater than 200. So what will be then? This is my 200 bytes I can send. The packet size of 200, which is 200, this is 200. This will be sent first. So what will be that? It will check the packet. Okay, I can send 200. Then I'm increasing from 200 to 400. Okay, so 200 to 400. Now I will check the next one. Okay, I can deliver with the 400. So while I'm seeing that, I will keep on check on my packet size which is available in the network, and I will send it. This is one of the example they gave, and this is the algorithm what I told you now. At every clock tick, a counter is initialized to a value n for every clock tick. Because then every clock tick, if length less than n, the transmitter counter n minus length of the first packet. So while we see n equal to 1000, n minus length of the first packet delivered. For example, when additional packets are in the queue sent along with the first packet, the total length will be less than n. Okay, so you see length equal to n, then transmitted. No other packets can be transmitted till the next clock tick. That is the example I told you that I am saying my n is 1000. I am saying first case n equal to, that is there will be 200. Okay, while I am seeing the total length is 1000. Once again, my total length is 1000, but I am saying that the n value is greater than 200. So automatically I can send my data with the size of 200 only. While I am seeing that, I am saying n is greater than 400. So the packet size of 400. So whatever maybe the total length will be 1000. But while we look up on that, depending upon the n, for every clock tick, this packet size will be keep on varying. For every clock tick, that's why they are saying there will be a transmitter counter, and depending on the length n only, my packet will be transferred. So it will wait for the next clock tick. Then so while we seeing that my n length is 1000, but while I'm seeing to that, I can able to transfer n greater than 200. Now I can deliver only with the 200 byte packet size only. Then I am saying next clock tick, that is 400. Now I can send only 400 byte. That's the thing. They were saying that this is the fixed flow. My fixed flow, what is it saying now? Every clock second, you see, from 0 to 1, 1 to 2, they are saying all the clock tick, the 3 Mbps, now it will be delivered with the 3 Mbps. So that is will be decided in the leaky bucket algorithm. So you all understand, this is my leaky bucket implementation. You all seen arrival, I told you, full now it will be discarded. No, now it will be put in the queue. After the queue, you all similar to the leaky bucket algorithm. remove packets at a constant rate. 200 byte of size now, I have to send 200 byte of packet size. 400 now, I have to send 400 byte of packet size. That will remove the packet at a constant rate, and then it will be processed, and then it will be departure. So there will be problem of occurring the bursting where my data rate is increasing in a stipulated time period. That will not happen. Here it will all deliver the packet or remove the packet at the constant rate. Is clear, students? Is clear? So you people may acknowledge. Always the students who went for the placement, only you people are listening, you may acknowledge it. Om Hope Brigade. Okay, are you listening? Bhuvaneshwaran is not connected with this audio. Vishwa, you want to say something? Vishwa? Okay. You take down this problem. Computer A has 19.5 MB to send on a network and transmit the data in a burst at C 6 Mbps. Okay. The maximum transmission rate across routers in the network is 4 Mbps. If computer A's transmission is saved using a leaky bucket algorithm, how much capacity must the queue in the bucket and hold not to discard any data? Okay, you all understand that the bursty means they are saying 6 Mbps. Okay, this is my 1 second, 0 to 1. My data rate is 6 megabits per second. Okay. So they were saying that 90.5 MB of data, what is the time it will require? 6 MB is transferred in 1 second. Now, what will be the time? Okay. So you just imagine, we all know megabytes. Bytes means if I want to convert, I always multiply into 8. Okay. So I will get it in megabit. You all know the difference. Capital B they used, that is bytes. You all don't forget. Okay. Small b they used, it's bits. Are you clear on that point? So previous case, we always say that bits per second only. Mega, MBPS. That means megabit per second. GBPS, gigabit per second. KBPS, kilobit per second. So you all understand that here 6 MB now, I'm going to deliver 90.5 MB megabytes now. I'm converting into 8 by using 1 byte equal to 8 bits. Okay. Now we all know that I converted 19.5 MB into 8. Okay. So what is the value I'm getting now? 156 MB I'm getting. 19. You please kindly work down this problem. Okay, 19.5 MB megabyte into 8. How many I'm getting more? 156 megabits. 156 megabits. Okay, and maximum translating rate they are saying 6 Mbps. So if I deliver, what will happen? 26 seconds. Okay, time for computer to transmit their data is 26 seconds. Okay. But what they were saying now, this is at maximum transmitted rate. But they are saying that only 4 Mbps is there. How will you transfer? At what time you will transfer? You just see 4 MB 1 second. Actual data sent on the network. Okay, actual data sent on the network is what, ma? 26 seconds. Okay, that we have calculated. So actual data sent on network is 26 seconds. Network rate into, we all know, into 26 seconds. So we all know what is this data, ma? What rate we are seeing? 4 Mbps, megabit per second. So if I multiply megabits per second into second, what I will get? Megabit per second into second, I will get megabits. So 4 into 26. 4 into 26, what is the value, ma? 104 megabits. So how will you convert that 104 megabits into bytes? How will you convert 104 megabits into bytes? I have to divide the value by 8. If I divide the value by 8, I will get 13 MB. Actually, the bucket size is 19.5 minus 13 MB. Now, it will hold the size of 6.5 MB. Yes, it will hold the size of 6.5 MB. You just see my 19.5 MB SATA, maximum burst rate is 6 Mbps. Okay, the maximum transmission across, they are saying 4 Mbps, you just take. Then a computer transmission is shaped using a leaky bucket. How much capacity the Q in the bucket hold not to discard any data. Okay, while I'm seeing that 6 Mbps per second, if I for transfer want to 19.5 MB data, na, I need only 26 seconds. Okay, and for 4 MB megabits per data, I can deliver in 1 second. Now, you just imagine how many data it can transfer now. 13 MB. So actual size is 19 MB. Okay, then the 13 MB. So I have to find out the Q in the bucket hold not to discard any data. 19.5 MB. Actual data sent on the network is 13. So 19 minus 13 is 6.5. So you all understand. Okay, my bucket size is 6.5 MB. Okay, and I am getting my data 19.5 megabit. Then I have to transfer with what speed bump? 4 megabit per second, because burst is occurring at 6 megabits second. 4 megabits per second. So the data which is sending now, that is 13 MB. 13 MB I have received it, and 6.5 MB is in bucket, and 9.5 MB is the total thing. So you all understand? Once again, I will redraw the diagram. 19.5 MB. And here my bucket is size is 6.5 MB. This is unregulated data flow, 19.5. Regulated data flow is 13 MB. 13 MB, what is the regulated data speed? 4 megabits per second. And this is my bucket, leaky bucket. This is my bucket capacity. And you all know it is burst at the rate of 6 Mbps. Actually, this you have to understand. Okay. So leaky bucket algorithm shapes the bursty traffic into a fixed traffic by averaging the data rate. It may drop the packet if the packet is full. Okay, sometimes it is. The token bucket allows bursty traffic rate at a regulated maximum rate. Okay, token bucket algorithm. The next one is we are going to see about the token bucket algorithm, because they have given leaky bucket, but sometimes there is a probability of asking token bucket also. So that is not a much difference. So you may learn both the leaky bucket algorithm as well as token bucket. So while we are seeing with that, leaky bucket, token bucket is improved version of leaky bucket, because the leaky bucket which can adjust the flow in case of bursty traffic only. But it allows sending bursty traffic when required up to the maximum size of the bucket. Okay, what it will do during the bursty traffic size, it will reduce to a constant rate and it will send the data. But token bucket is nothing but during the bursty traffic condition also it will send the data. That is they are saying. I think this is the image which you gives for the token bucket algorithm. So you just see my host computer were sending one token is added to the bucket in every DT seconds. And here what they will do, everything, one token is added to the bucket. So you just see this bucket hold the token. So which I have to send first, which I have to send next and all. So this image is before token and this image is after token or transfer. It's similar to the token what we were getting now, the same way token buckets are there. So depending upon that, Here, so many things will be there, but according to the token number, it will be delivered to the network side. Okay. So I think you may take this formula for the calculation. This is the algorithm. A token is added to every delta t time. There we see now every ticket, every tick, there will be a updation of packet size. Now, similarly, a token is added to every delta t time. The backend can hold almost B tokens. How many tokens it will hold in a B tokens? When a packet of M bytes arrived at M tokens are removed from the bucket. So bucket can hold B tokens and the packet size is M bytes and M tokens are removed from the packet and sent to the network. If less than N tokens are available, no tokens are removed from the packet. That is non-conformant. Non-conformant, there will be no tokens are removed from them. So you just take down this formula. We see the one small. C is the maximum bucket size. Rho is the arrival rate. S is the burst size. And M is the maximum output rate. We will see with one example. Okay. C plus rho S equal to MS. C is the maximum capacity of the bucket. Rho is the arrival rate. M is the maximum output rate. And burst length will be S. C plus rho S. Okay. Now, token bucket algorithm. Consider a frame related network. 1 MB of data arriving at 25 megabit per second for 40 milliseconds. Okay, the token arrival rate is 2 Mbps and the capacity of packet is 500 KB with the maximum output rate 25 Mbps. Calculate the total length, total burst length, total output time period. Okay. Now you see what is the maximum bucket size. See they are saying maximum bucket size. C equal to what, ma? 500 KB. 500 KB. Okay. M, maximum output rate. M is 25 Mbps. And at what rate? The arriving rate is nothing but rho. Okay. Arriving rate, where the arriving rate is there. And this is my arriving rate. This is rho. So I know C value, M value, rho value. Okay. Next, I have to find out the burst size. We all know the formula. C plus rho S equal to MS. Okay, so C plus rho S is equal to MS. Listen, what they said told me, C is the capacity of bucket. That is 500 KB. Okay, rho is my arrival rate. That is 2 megabit per second. M is the maximum output rate, 25 megabit per second. So I have to calculate S. So from this calculation, how will you calculate? C equal to, I can take S common, M minus rho. So S equal to what now? C by S equal to what is the value now? C by M minus rho. So I can say that my burst time will be 22 milliseconds. So for 22 milliseconds, the output rate is 25, they are fixed 25 milliseconds. After the output rate becomes 2 Mbps, that is the token arrival rate. So we have find out that my S value they are saying 22 milliseconds. So totally, what will be my capacity now? 500 KB. Okay, 500 KB, we all know that the output rate will be 2 Mbps. So 500, 2 Mbps now, 2 into 10 power 3, that is 2000. So what will be the value now? 250 milliseconds. So 250 plus 22 now, 272. The output time will be 272. So for 22 milliseconds, the output rate is 25 milliseconds now. After the output becomes 2 Mbps, definitely the token arrival rate will come. Therefore, 5 KB I want to send now. So automatically you just understand that in this way, I have a token. I have sent out at the every del T, and you all know that the maximum burst size is 22 milliseconds. We all know the formula S equal to C by M minus rho. This is the formula. I have calculated my burst size, and from the burst size, I have calculated if I want to transfer 500 KB of data. Okay, 500 KB of data, then automatically what will be the total output time? That divided by arrival rate is, we all know token bucket is delivering 2 MB, that is arrival rate 5 to 500 divided by 2000, 250. So you all know that 250 millisecond, the 22 millisecond will be the burst size. So 22 millisecond is my burst size. So that will predict that burst size earlier. That is the thing. Okay. So this is one token added. You all know, instead of token bucket, leaky bucket algorithm, one token removed and discarded per cell transmitted. So one token at every del T, the token will be received here. We all know, to find out the maximum burst size, we use this formula, C equal to M minus rho. C is the total capacity, M is the maximum output rate, and rho is the arrival rate, where I can calculate the maximum burst size, what I can, and then to deliver the capacity entire, I want to clear this scene, I can calculate my total time period also. So the same thing, you all understand this scheduling concept or reshaping concept, they follow the queue only. Okay, in the queue we have FIFO queue, waiting queue, and priority queue, and then we have a concept of leaky bucket queue, token bucket queue, all this will be there. Okay. The difference between the leaky bucket and token bucket. Okay, while we see that it is a token dependent, because leaky and this is a token independent, because token bucket depends on the token, one token every time. Okay, if bucket is full, token are discarded but not the packet. Okay, it's full token we are discarded, but not the packet. But here, if the bucket is full, packet or data, it will contains here token only, but here it contains the data. But while I'm discarding my token, but not the packet. Okay, packet can only transmit when there are enough tokens. Packets are transmitted continuously. It allows large burst, but you all know here burst flow. That's why I told you we have calculated the burst flow in the token bucket algorithm. It says token to send large burst. Okay, in this 22 millisecond, I am sending my large burst of data that will intimate it to the network. But here it does not. The leaky bucket algorithm always focus on constant rate. Token bucket algorithm can send the data during the burst time also, but burst time will be calculated and will be priorly informed. And here you all know bucket is full now, packet is full, and packet will be continuously transmitted. Here packets can only transmitted when there are enough token only. If the token is there, I can transmit by packet. So if there is no token, I cannot able to transfer the packet. So none of the packet will not be discarded. This is the meaning of that. Okay. I will upload this PPT, ma. So last we have seen a resource reservation and admission control method while we are seeing the quality of QoS. So while we are seeing this resource reservation and admission control. So what are the resource they will reserve? Now, buffer, CPU time, bandwidth, or the resource that can be reserved for particular flow for the particular time to maintain the quality of service. Okay. Admission control. Admission control, we already seen the admission control mechanism while we are discussing about the congestion control. So my router can know that whether I want to accept or reject the flow based on the flow specification. That is called as a admission control. So this is about the quality of, so you just see the entire slide. We have give the expression for the congestion control as well as the quality of service. So congestion control, we have explained about this data, traffic and traffic profile, and congestion. Two types of congestion controls are there. So these are the two parameters. Okay, open loop and closed loop that we have seen. That's why I told you the admission policy we have already seen in the congestion control. Same thing is available in the quality of service. Okay, and then these are the closed loop mechanism of congestion control. And then we have seen the congestion control with the two examples. One in TCP, we are seeing that slow start exponential increase, and then congestion avoidance using additive increase. And then TCP congestion policy, that is we have seen that multiplicative decrease. And quality of service. Quality of service, we have a flow characteristics. So we have a reliability, delay, jitter, bandwidth, all this we have. So we have discussed about all this in detail. And then we have gone with the scheduling algorithm. In scheduling algorithm, we have a FIFO, priority weighted per queue. And we have seen about this random early detection. And traffic shape, we have a leaky bucket and token bucket algorithm. This is very, very important. The leaky bucket algorithm and token bucket algorithm. Leaky bucket can deliver only at a constant rate. Token bucket can able to deliver one during the burst rate also. That's why we have the small calculation for the token bucket algorithm. And after completing that, we have a comparison and resource reservation and admission control. Is clear? Students? Okay, I think I will post this PPT as well as this video content in the file. You may refer it for further purpose.